Okay, based on the work that we've done so far and the work we just did, the commutative property is the one where you can switch the two numbers. Like 2 times 3 is the same as 3 times 2. That's the commutative property. Does it hold for matrices? Well, definitely not when matrices have different dimensions. Like the dimensions on this guy are what again? 2 by 3, and the dimensions on this one are 3 by 2. So we can actually answer this question by just doing a dimensional analysis. Can we multiply these two matrices together? Yes, and the result will be AB with dimensions what? 2 by 2. Now if we try to use the commutative property, we'll have AB, instead of AB it'll be BA. What will the dimensions of B times A be? 3 by 3. Now, without actually doing the math, does the commutative property hold for matrices? No, it doesn't, because these aren't even the same dimensions. Now, what if we had a 2 by 2 and a 2 by 2? Does the commutative property hold there? Did it hold here? You know what a counterexample is? An example of something that proves something false, right? Does this example prove the commutative property false for matrices? Yes. So therefore, even if I had a 2 by 2 times a 2 by 2, does the commutative property hold? No. It might be a coincidence that B times A is the same as A times B, but that would just be coincidence. We've already proven that the commutative property does not hold for matrices. Okay, so even though the dimensions are the same, it does not hold. So the answer to this would be no. What about the distributive property? Does it still work with matrices? So I'm giving you matrices A, B, and C, and I want to see if A times the quantity B plus C is the same as AB plus AC. We need to figure out if potentially the distributive property holds. So let's do the left side first, and then we'll do the right side. So we're going to have to multiply a couple of matrices together. We'll have to add these two things together here. Let's do the left side first. We need B plus C. So if I write all this out, it will be the matrix A, which is 2, -1, 1, 3, times the matrix B, which is 4, 6, -2, 5, plus the matrix C, which is -3, 7, -4, 8. So I'm just writing that all out nice and formally. We can add these two things together right now. So I'll still have the matrix 2, -1, 1, 3. That's my matrix A. And it will be times the result of these two things being added together. And we know how to add matrices together. Just add the corresponding components. So 4 plus -3 is 1. 6 plus 7 is 13. -2 plus -4 is -6. And then 5 plus 8 is also 13. Okay, so now we just need to multiply these two matrices together, and we'll have our answer for the left side, and then we'll go to work on the right side. So to multiply these together, we have a 2 by 2 times a 2 by 2, which will give me a 2 by 2. You may be to the point where you can do most of this math in your head and just come up with the answer, and that's fine. 2 times 1 is 2. -1 times -6 is positive 6. 2 plus 6 is 8. First row, second column. So first row, second column. 2 times 13 is 26. -1 times 13 is -13. 26 minus 13 is 13. For this position, that's second row, first column. So second row, first column. 1 times 1 is 1. 3 times -6 is -18. 1 plus -18 is -17. Finally, second row, second column. So second row, second column. 1 times 13 is 13. 3 times 13 is 39. 13 plus 39 is 52.
How do you know how to multiply them?
All right, so that's the left side. Now on the right side, we're going to try to do this, as if we had distributed the A in and wound up with A times B plus A times C. Okay, that's just, does the distributive property work? So now we need to multiply AB and add it to AC. So AB, we don't need to write this down again. We'll have AB equals, it's a 2 by 2 times a 2 by 2. So we'll have a 2 by 2. For the first position here, row 1, column 1. That's row 1, column 1. So 2 times 4 is 8. Negative 1 times negative 2 is positive 2. We get 10. Twelve minus 5 is 7. Second row, first column, which is negative 2. And second row, second column, 21. All right, so that's AB. Now we need AC. Once we get that, we'll add them together. So AC equals another 2 by 2. First row, first column. Negative 2. First row, second column. Positive 6. Second row, first column. Negative 3 plus negative 12 is negative 15. And second row, second column. Seven and 24. 31. Okay, so now we need to add AB plus AC to see if we get the same result. And I'm just going to draw a line like this and add. That's pretty informal there, but really we're just adding these two matrices together. So we'll wind up with a 2 by 2, and I'm adding corresponding components. So 10 plus negative 2 is 8. 7 plus 6 is 13. Negative 2 plus negative 15 is negative 17. And then 21 plus 31 is 52. And we got the exact same result. So because of this one example, do you think that maybe the distributive property works? It could. That's a good answer. It could. We have one example where it worked. Okay? So it's possible that it does work. Whereas before we had one example that proved that it didn't work with that commutative property thing. So actually it turns out the distributive property does work. And here we have some properties of matrix multiplication. The associative property of matrix multiplication works. You can do AB first and then times C, or you can do BC first and multiply that result times A, as long as it's in this order. The ABC stays in the same order. The associative property of scalar multiplication. So here I have AB and I'm multiplying in some scalar. I can multiply that scalar times the matrix A, or I can multiply that scalar times the matrix B and then continue the problem. Either way, it doesn't matter. The part that we definitely need to talk about is here and here. The left distributive property is the one we were just looking at, where you have a matrix out front times two matrices being added together. The left distributive property says, yes, it works. But we also have now a right distributive property, and this is probably the trickiest part of the whole day right here. The right distributive property has a matrix being multiplied on the right side times two matrices that are being added together on the left side. You can distribute just like before, but now when you distribute, it will be AC plus BC. That's different than up here, where when we distribute that C in, notice the C on the left side stays on the left side. The C on the left side here stays on the left side. Now the C is on the right side. When we distribute that in, the C stays on the right side. So order with matrices matters. Make sure you're being careful about left distributive property and right distributive property. And that's what these words down here are saying. Notice the distributive property works from the left and right side. This is different than what you're used to working with, so make sure you're careful when multiplying. Also remember that the commutative property does not work with matrices. Doesn't matter what the dimensions are. You can't assume that the commutative property works. Your calculator will do all this work for you, so you might as well know how to do it. Let's go back to the 3 by 5 times the 5 by 3 problem that we're working on, or that we just did a dimensional thing on it, and we said, no, it doesn't work. Let's enter those in. We have a button on our calculator, the template button. We've used this button before. The button or the icon that's highlighted there is the 3 by 3 matrix. The 3 by 3 matrix is the one that allows you to choose the dimensions of your matrix, and that's the one we need here. So I want, for matrix A, 2 rows, so I'm going to delete and press 2, and for matrix B, I want 3 columns, so that's perfect. I'm just going to press enter, and it gives me my 3 by 3 matrix. Now, if there's a bunch of stuff that I'm going to be doing with these matrices, then I want to enter this matrix in and press enter so that it's in there. If I'm only doing one thing with this matrix, like for example in this problem, I'm only multiplying A times B, I could just enter in this matrix times the other matrix and press enter and get my answer. But I don't want to do that here. I want to actually enter these in. So the matrix will be 1, 3, negative 5, and then be careful, go down to the second row, 4, negative 2, and 0. And I'm going to press enter so that it's locked in there. Now I can go back and select it to do lots of different stuff with this single matrix. I'm going to enter in matrix B now. So I'll need to go back to my template, select my 3 by 3 matrix again, and this time I need a 3 by 2. 3 rows, 2 columns. So I'll press enter, there's my matrix, and I'm going to enter that one in, 2, 3, and my second row, negative 2, 8, negative 2, negative 8, and then my third row, 1, 7. And press enter. Now once I'm there, I can do anything I want to this, and there's actually lots of things that you can do to matrices. We've learned a little bit. By the time we're done with this chapter, there's a lot of stuff that we can do. So first thing I want to do is multiply A times B, because on this problem we're trying to see if the commutative property holds. So even though we know that it doesn't on this one, let's do A times B. So matrix A was the top one. I'm going to go back and select it, and then I'm going to press times, and go up and select my other one, and press enter. Now I have those two matrices being multiplied together. I press enter, and it gives me my answer. It's 2 by 2. Don't have to do any work there. It does it all for you. It's kind of nice. Now I want to do B times A. So I'm going to go back up and select matrix B first, and then times, go back up to the very top and select matrix A. There it is. Press enter, and there's my 3 by 3. So we already knew that this didn't work, but just to show you that you do get two different results, a 2 by 2 and a 3 by 3, and there's the results for you. So feel free to use your calculators to multiply these matrices together. Just make sure you're doing them correctly. There's no hope for you if you're not showing work and you're giving me wrong answers. Okay, so just make sure you're doing that right. Also, matrices will, calculators will allow you to add and subtract and multiply them all the same. And you do that just like you would expect. So if I wanted to add these two matrices together, like maybe I'll just pick that one, plus, so plus, and then that one. Will the calculator like this one? No, because the dimensions don't match. So when I press enter, I should see, yeah, and I do. Dimension mismatch. So it's going to tell me when I've done something wrong. But that's basically the notation that you'll have to use to add or subtract matrices as well. So feel free to use this instead of doing it by hand from now on.